This is a help video for transformations with equations. In absolute value equations, multiplying a and x will give you your slope. If you subtract 8, it will move your equation to the right. If you add it, it will move it to the left. If you add k, it will move your equation up. And if you subtract k, it will move your equation down. In our example, multiplying negative 1 and 2 gives you a total slope of negative 2. Adding 2 causes the equation to shift to the left by 2 units. And subtracting 4 causes it to shift down by 4 units.
We have equations like these. When you add c, it is outside the parentheses of x, it is going to move up. When you subtract c, it is going to move down. If c is inside the parentheses, if you add c, it's going to move it to the left. If you subtract c, it's going to move it to the right. This is your parent function, y equals x. And so in this equation, there is no parentheses, and you add 2, so it's going to move up 2 from the original function. And in this, you have 1 inside the parentheses and outside, so you're going to move it to the right 2, but also up 3. The rules on top apply when you have an equation like y equals c times f of x, and c is outside the parentheses, and so if c is greater than 1, then it is a stretch. But if c is greater than 0, but less than 1, it is a compress. And down here is different because you have y equals f times cx, and c is inside the parentheses with x, and so these rules are switched. On this equation, because c is greater than 1 and there's no parentheses, it's going to be a stretch by 2. On this one, because there's 1 inside and outside, it is going to be compressed by 3 and then stretched by 3.
When reflecting over the x-axis, you use the function y times negative f of x, which represents that the whole function itself is being multiplied by negative 1. When reflecting over the y-axis, you use the function y equals f times negative x, showing that the base variable of your equation is being multiplied by negative 1. In our examples, we see that our equation is multiplied by 2, causing it to stretch, and it is reflected over the x-axis. In this example, it is instead compressed by a factor of 2 and reflected over the x-axis. This is an example that would be seen on a test where we put everything together. Our parent function is y equals x. This has been turned into our example shown. Our negative represents reflection over the x-axis. 3 represents a stretch of 3. And adding 2 represents our equation being moved up 2. We now have another example in which negative represents that it gets reflected over the y-axis with a slope of 1 because x has no base. It is then moved to the right 9 and moved up 2.